Okay, so we're going to look at an alternate way to solve quadratics. So what you may have noticed is that not all quadratics are factorable. This one is. We actually could figure out the answers. We need to find things that multiply to negative 14 and add to negative 5. So that is going to be negative 7 and positive 2. So the factored form would be x minus 7 times x plus 2 equals 0. And then I could use my zero product to figure out what makes this 0. So what makes this 0? X would be 7. And what makes this 0? X would be negative 2. So we already know the answers going into this problem because we could solve it by factoring. But it's kind of this magical unicorn where you can actually find numbers that multiply and add to that number, and we can factor it. So let's look at an alternate way to solve quadratic equations. So mathematicians came up with this formula that works, and it's based on the numbers that are in front of each of the variables or the terms in the quadratic expression. So the number in front of the x squared term is a, the number in front of the x term is b, and the number that is the constant is c. Okay. So this is our quadratic formula. We're going to plug those numbers in. So everywhere we see a b, we're going to substitute the value of b. Everywhere we see an a, we're going to substitute the value of a, so on and so forth. I'm going to sing a little song for you. It goes to the tune of the Pop Goes the Weasel. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Just a way that can help you remember it. So if I'm setting this up, x equals negative b. Now if I look at b, well, b is already negative 5. So it's really negative 5. Or when I kind of get to my next step, I'm just going to go ahead and make that positive 5. Negative b plus or minus the square root of b squared. So I want to put that in parentheses because I do want to square the negative. And really, anytime you square a negative, it's going to be a positive. So you could almost ignore that and just write 25. Minus 4ac, so a is 1, c is negative 14. So I'm going to multiply all those together. So 4 times 1 is 4 times 14 is 40 plus 16. So that's 56, I think. 40, oh, yeah, 56. So it's plus, really, because we have two negatives. So plus 56 all over 2a. So a is 1. 2 times 1 is just 2. So I'm going to go ahead and simplify this. X equals 5 plus or minus 25 plus 56. That's 81 over 2. Now I can actually go ahead and kind of see what I'm doing. I'm adding and subtracting. I actually know the square root of 81 as well. So 5 add 9 divided by 2, or 5 subtract 9 divided by 2. So when I do 5 plus 9, I get 14 divided by 2, which is 7. Same answer we got before. And I do 5 minus 9, that's negative 4 divided by 2 is negative 2. So I get my two answers for x. X equals 7 and x equals negative 2. Now, in this case, the square root was nice because this was actually factorable. It had two rational answers. But when the answers are irrational or not nice numbers, right, like a non-repeating decimal where the square root doesn't come out nicely, we can still approximate the values of x using the quadratic formula, which is the nice part. All right, let's take a look at this next example. In this next example, we do need to make sure it has that certain structure before we start. So it should have a 0, and then we should have it lined up A, B, C. So I'm going to actually subtract 4 before I get started, because I want it to be set equal to 0. So I have 4x squared plus 8x plus 3 equals 0. So this is my A, this is my B, this is my C. So A is 4, B is 8, C is 3. So then I'm going to sing my song. X equals negative B, which in this case is 8, plus or minus the square root of B squared. So 8 squared minus 4, A is 4, C 3. All over 2a. So I'm going to go ahead and simplify this. Negative 8, add or subtract 64, and then I'm going to multiply these three numbers together. So that's 16 times 3 minus 48, all over 2 times 4 over 8. So I'm going to do 64 minus 48. Okay, So I get negative 8 plus or minus the square root of 16 all divided by 8. Which if I add, I get negative 8 plus 4, because the square root of 16 is 4, divided by 8. Negative 8 minus 4 divided by 8. So these are still rational numbers because I can still find the square root of 16. It's going to come out a little bit messier. They're actually fractions. But for example, if I had gotten like the square root of 14, then I would just go ahead and figure out what that is about as a decimal. So we know that would be like 3 point something. And then we could use that number instead. So negative 8 plus, let's just finish this one out, negative 8 plus 4. Negative 4 divided by 8, so negative 1/2. And negative 12 divided by 8, that's going to give me, I can reduce those, I can divide those both by 4, so negative 3/2. Now, if you wanted to check your answers, these are answers for x that should make this equation true. So I'm actually going to go back, and I might use my calculator to plug these in, or just kind of go ahead and plug them in and make sure that they work in that original equation. So for a half squared is really a half times a half, and the negative times a negative gives me a positive. So a half times a half is a fourth. And then half times 8, that's going to be minus 4 plus 4, and I want it to come out to 4 on the other side. So I'm just checking it by plugging it into the original x spots, and I'd have to check each answer separately. So 4 times the fourth, 1 minus 4 plus 4 equals 4. Wondering if I made a mistake because this doesn't seem to be looking out. 1 equals 4. All right, let's go back here. I wonder if I made a mistake. 4ac all over 2a. Negative 8 plus 4. Just checking my work. I'm figuring, oh, I must have made a mistake somewhere because this isn't coming out right. Maybe it's in my check that I actually made a mistake. So the other thing that I could do is go to Desmos.com and I could graph this, but I'd have to graph it when it's set equal to 0 and see what the x-intercepts are. So the x-intercepts are negative 1/2. So I must have made some error in my arithmetic here. Let's see. Oh, I copied down part of this wrong. This is actually supposed to be a 7, not a 4. So that's a 7, which will make this work out. Okay, so then this is 1. There we go. 1 minus 4, negative 3 plus 7, and I get 4 equals 4. So checking your work can be really helpful, so I know that that one works. If I wanted to plug the other one in, 4 times negative 1.5 squared plus 8 times negative 1.5 plus 7, get that right this time, equals 4. So then you could use a calculator to square 1.5 if you wanted, or you could use its fraction form, 3 over 2 times 3 over 2, so 4 times 9 over 4, which is going to give me 9, and then 8 times negative 1.5 is going to give me negative 8, and then an additional 4, so minus 12 plus 7. Does that equal 4? Let's see. So 9 minus 12, negative 3 plus 7 equals 4. 4 equals 4. So I know that that answer, negative 1.5 or negative 3 over 2, also works.